started solving it out by hand here, and I got the same thing as that little calculator thing online got. However, I can't guarantee it's orthonormality. I don't know how to transform this to be
just
orthonormal.
follow the same steps what I do without.
Because that's why I went to his office yesterday. He said,
The
"Oh yeah, you can solve it this way, and then you can, you know, do simultaneous system of equation, find out what the magnitude of the eigenvector is for W. However, that doesn't satisfy the conditions for orthonormality."
Well, I think if
You
you
need
do
a parasol.
this,
Yeah,
Okay,
relation
very solid.
would ensure orthonormality.
And after this, I'm going to change.
and that's fine. I
You
can
see
do
this is
that. It's just I
parasol.
don't.
XT means parasol.
That's where I stopped. It was 1 in the morning, and I was like trying to find the inverse by hand.
Oh Jesus, no! I don't think. Do we need to find this inverse?
So ICEM
Well, the
CFD
thing
is that
by
That's a meshing
computer,
software.
then it gives it
okay?
to us
And that's in
double
ANSYS.
Yeah.
In what?
Import geometry.
digits, like 0.736
That's all.
something. Reusable from alpha.
Yeah.
Millimeters.
Well,
Millimeters.
Let's see.
Apply.
it's pretty much the transpose of the inverse.
Surfaces. Okay.
Create part inlet. Going to select inlets. That's it. Okay.
Okay.
Just
So,
click say yes.
so create a part inlet.
And when you're clicking, click the wheel button like for apply, or if not, you can click apply over here. Then it's C. Click here, go here, just click on the part, click the middle wheel button. Yes, or you can just directly put apply.
Because he did say we can use
Okay.
MATLAB from alpha to
Oh.
find the inverse of the matrix.
Yeah.
Outlet.
Finding
Click.
this by hand would just be.
Click.
Okay.
Easy peasy.
Inlet, outlet. I'm just blanking there.
Okay.
Then if we have your nose body, so
Mm-hmm.
put nose. Click on select everything.
Okay.
And just like look into this, it's just like apply. Nosecone.
I was
Okay,
gonna ask,
so we are done with name selections or
what
like
did you do
parts
for
into
lambda
it.
-4 to find
Then
the
now we have to create a fluid zone inside it. Go to geometry, go to this box,
I did the same thing.
click over here, just put fluid in here.
which is
Just
Take 2 points
put in
fixed.
this one
Any
for-
point on the
Right.
domain
Or
start
actually,
and any
that's
end
what I
point on
think
the
we need to
domain end.
because,
And then
these
just
equations
apply.
they're pretty much
Okay,
redundant,
apply
so
means clicking
you'll
middle
find
wheel
that
button.
SMY is equal to 0
Mhm.
and you can just assume Z to be
And
equal
after this, you see you should have something like this, fluid
just
inside.
assume it equal to
Okay.
After that, just save it. Save as
Oh,
project
So
or
any
whatever.
vector
Okay.
like
Okay.
001,
Okay.
005 is
And
going
after
to be
this,
orthonormal.
go back to meshing attributes. Meshing.
Oh, because it's
Go
over.
to
It's an
global
overdetermined
because this is
system.
300 mm. I'm going to give the maximum cell size is like 100 mm. Yeah. 300, 1500, 100 mm. Yeah, 100 mm should be fine maximum size. And get back here and then just go back to inlet as 100. Nose as I'm going to give like 10. This is the first iteration just to see
But
what
I went up to his office hours last night.
symmetry 100.
5 as he was leaving.
Okay,
shit.
and for here for the nose
really
cone you need prism layers, height of 1.22 and height, oh sorry, height of 0.005 and height of 1.22. Now look, layers change. Then apply. Just give the same settings, don't change them, okay?
Okay.
And then just go click here, click on the volume mesh, compute.
Okay, so hold up, I need to put this in. How do you put this into Wolfram?
That's the
You
same.
just use curly brackets.
We can have much better mesh, right?
Okay.
Click here,
Curling brackets. So pretty much do the same thing like I would in
5.
MATLAB.
Yeah,
Apply.
except, yeah, you, so you put like,
One
you
here,
open up the
one
matrix with
here,
curly
compute.
brackets and you open up the first
Replace.
line with curly brackets.
until and unless your mesh is like completely satisfactory.
So until it's small enough that it actually really approximates the geometry well.
True.
Totally forgot. I reinstalled my operating system.
So that's pretty good. Does that
No.
count as a?
I have the internet.
Around 2 million. No, 300,000. So
I just don't have a Wi-Fi
we can still go
enabled.
little more like.
Okay.
Okay, I don't see much in here, so I think we need to change this property.
You need to re-enable your
It's
Mac
right
address.
here at the desk point.
Okay.
The Mac address shouldn't change though.
Offline. Get back here. Just give it like 2. I'm just trying to make it more.
I don't know how to do that.
Okay.
Let's just remove any systems.
I wonder at this point if it's CPU or GPU intensive for this kind of thing.
So you
I wonder if it's CPU or GPU intensive for this sort of thing, creating the meshes, and
GPU then?
whether it's CPU or GPU intensive.
I don't understand. I don't know.
Oh, just what does it use to make the?
I see. No, I really don't get you. Just a second.
What? That's not why I put it on.
Just
What building is this classified under? Oh, F.
Okay, so what was your question? I'm sorry.
Yep.
What was your question?
Oh, it was just a general computing question. It wasn't anything.
Okay. So if you see this, we have enough mesh. What's the size? Size like 800, near to 1 million. So we can just go click on prisms. For that, if I just change it to 5, it should be enough.
I'm trying to find inverse.
You guys do realize that when Lithograph has its exams, he's going to ask you to do just
Do what?
the inverse.
Yeah, but not.
So when you change it down to 5 from 10 layers, what is that doing? Is that putting?
That is inflating. Like you have a wall, you're creating a volume mesh, right?
Mhm.
It's inflating the
I asked him. He said that
the cells,
you
like
can
the
use that level.
mesh from the wall to the cell,
Mhm.
the gap. It's covering the boundary layer.
Oh, okay. So instead of 10 layers in that boundary layer, it's only 5.
Yeah.
But it's
Okay.
a long process.
Yeah. Yeah.
Uh,
A, B, C, D. What is A, B, C, D?
So if a 2x2 matrix with A, B, C, D.
It's a 3x3.
Yeah. So you just type trap another curly bracket. That's gonna open the first line. So you put
This is the first row or column?
first row.
Oh, okay. Alright.
And you separate the things by commas.
Okay.
And then
Got
you
it.
end the first row with another curly bracket. Start the next row.
That's interesting. 1, 1, 0. What's imaginary? Is that just I for this
Yeah.
thing?
Yeah.
Okay.
It's having a heck of a time trying to get that to work now.
Yeah, it needs to.
Alrighty.
It needs time. See. Yep, it's done. Okay. 1 million should be fine because this is a supersonic speed, so
It's not hypersonic, so you don't need quite as many as Oach.
but this one we have caps and outside to control. Okay, so once you're done, save the project names. Then go here, output, click on this box, just say ANSYS fluent and ANSYS, say apply, done. Get back to boundary conditions, go click here and surfaces one side. Inlet is lost, oh no, for you pressure 5 feet. Okay? And so this is wall. Outlet is pressure outlet.
Okay.
Symmetry is symmetry.
And have some kind of dedicated surfaces for
Okay.
this.
After that, just go click here. It allows you to save it. Save it,
So that
and then
it
it will ask you this one. Just open. You don't need to do anything. Just give. Don't miss anything over here, because if you just miss one of the slashes or something, then it's gone. So just put fluent. Just save it. Okay. So once it comes done, it will give you done with translation. So once it is done, that means you're done. So you can just go exit. It will ask you to save again. Save it.
Okay.
And then just close it. So we have, this is your mesh. You can just name this one to your mesh.
Or we have to force sensor just
.msh is the extension. Don't change with the extension.
Right.
Okay, now get into folder fluent. Okay, just go click this. Click this. Put this in here.
Sorry.
Go. Copy. Go. Fluent. 3D double precision. Display mesh after this. Graphic embedded windows. Color scheme. Parallel or serial. You can use serial if you're using something on your laptop. If you're using something on like college computer, school computer downstairs, you can just go for parallel one.
Okay, so when it's parallel,
Just give like 8 nodes over here instead of 10.
So-
I have like more GPU computing power capacity for this computer, so I've given higher.
Okay.
So just give like 4 or 5,
Yeah.
or like just give even number instead of odd.
Wolfram doesn't
Just
simplify.
click on this and then click OK.
It does.
is the parallel, is that something with how many cores you have in your CPU?
Yeah.
So your computer has...
My computer has 32
Yeah,
cores.
but it would make other
Okay,
weird
file,
terms on the other one, so just
read,
it out.
file, read, mesh. Go, click on that mesh, click OK.
Every term simplifies.
If you see, this is your current directory. Okay, you see your mesh?
Mm-hmm.
Now, it'll ask for scale. Because you've made it mesh in mm, click mm,
Mm-hmm.
and you have to view length in meters. Just scale.
Yo,
Okay.
here's my
Alright.
And then
I should
just
calculate A.
done.
You first
Check.
start out.
This is
Yes.
calculate.
why.
So to
You have
calculate
a mesh.
yeah, like so the first value, right? Minus 4 times 001, which is the associated eigenvector. And then times W transpose, like what?
Okay,
Yeah,
never mind.
so
I'll
he's
just
not
show you the
talking
setup.
about the
I'll
entire
change the mesh
matrix,
again. I
he's
don't
talking
want
about
to
the
write
vectors.
it.
Yeah, the vector. So, but what vector are we supposed
Change
to
this right now.
Because
So once you
The one
put
that's
check, it
associated
should
with,
give you a mesh check done.
Mm-hmm.
Okay, then only
With
it
the
is valid. If
which
not,
would be
you will
this.
not have valid results. I'll change the mesh and give you. Okay.
No.
Models.
It
Click
would
on
be one,
energy
zero, zero,
equation.
five.
Double click.
Is
Okay.
it this?
Yes.
click on, okay, this one, K omega, go for SST. Okay?
Okay.
Yes, because
Materials,
you know
air,
that W.
double click on that. It's ideal gas, viscosity, solar lamp. Okay, change and create.
If you look at the respective,
Cell zone conditions,
mine's
it's
interesting.
1, 2, oh, okay, sorry, I don't know what was the value, 1325. Just give the same value.
Whatever value it is at whatever altitude it's supposed to be.
Yeah, altitude it is, so just give the same one. And in inlet, pressure far field, edit, gauge pressure should, okay. Here in this case, just take off this, put 0 instead of that, because it
I have
will
an I, so you don't have an I.
0, 1,
This
2,
side
5. Okay?
W. I have an I here, I here. I there. Oh no. Oh, I'm sorry. Yours are.
Mach number?
My first two are the
It's like,
complex, and my last
yeah.
one's the real part. So yeah, no, it's this column here.
So we can just, as long as we take this pressure far field boundary condition and we change that Mach number, then whatever.
Yeah. 300, okay.
My last row.
Outlet,
It's not
edit,
separated by row. though,
gauge
it's by
pressure
column.
is 101325.
So I'm finding weird. Because in this case,
300, inlet. So what's the radius of this?
The radius of the model, it's 3 1/4, so it's 1.725 inches.
Can you just tell me in inches to
Yeah, here you go. I got you. You got the calculator.
1.73 inches.
oh, never mind.
I just need a rough number though.
Yeah, 1375.
No, 0.043. Like I'll take it as 0.044.
Okay.
0.044 pi r square. Like area is pi r square, right?
Mhm.
This is your diameter. Oh, this is radius or diameter?
That's radius.
Okay. So calculator 44 pi r this is your area, 0.00608, and your length is 0.3 meters.
Mhm.
Just give 0.3 and fluid. Simple, don't change this, use second, step, first order.
Oh, I don't know, you have to check out.
First order. Those just give default values.
Because I've read that this one is more for dynamic systems. So I can try out this. Otherwise,
I mean, the question is always what the thresholds are, right? So what this could be here is that your noise is getting in above and below the threshold level. That's how you get that response.
So why are you putting them all to 1/2 values?
It has a very deep numerical calculation concern in it. It's just to make the solution more stable.
Oh, okay.
Okay. In simple words. Okay, I'm just changing the default values so that it suits our simulation. Okay.
because I've had to put my boundaries
Just go. Don't uncheck these. Generally, I prefer you uncheck it, but for now, like just to understand, it will give you. You're looking for drag, right?
Yes. Drag, not necessarily
What do you want?
lift. And then just the shock
Okay, so that's alpha 0. So that's what I given. Just go click on standard initialization, get back to initial inlet, just put initialize.
Okay.
Okay, and then do like just save 500 after every 500 iterations. Just save. Go run calculations like for 1000 or something until and unless your solution is converged. Just click and then calculate. Because mesh check is failed, so it will give me some values.
Now I have to type this in.
I don't think they're bad though.
Now I have to type this in.
Okay.
What the?
So that's it. And then
Yeah,
once you're done with this, like once it is converged, it will show that solution is done. And that's the head. And after this,
What contribution to the thing?
Are you trying to bridge a piece? Maria?
so just go here,
No, dear, you're gonna make me laugh.
courses.
My legs feel like shit. Alright, so that's
Okay.
That's it. That will give you the values. If you change this, change it one,
Wait, before you
and then
type
print,
that,
that gives
yeah,
you lift
let's
value.
raise.
Lift is in right direction, right?
Okay.
I could do it.
This gives you side force.
Write it out
okay.
by hand.
Okay.
Okay, close this.
Oh yeah.
So the
Yeah. Let's go. Ready?
Yeah, just like
Alright.
3, 2, 1. Go.
Yeah, so I'll try.
after this, just write like file
But now
write
keep in
piece and
mind
data,
though, you want to do it.
okay.
just to save everything.
You want to keep
Mhm.
terms
Okay.
separated. He said.
After
You don't
that,
want
I'm
to
like I'm
simplify it,
okay.
find
Do you want me
A,
to
he said
save
keep
it for you?
separated.
Just in case
Yeah.
if you have to
Each
save.
of the sums.
Alright.
Do the same thing. I'm pretty
So
sure
all
the
you have to do
icing thing, whatever you do, it will work.
Okay. And then have like
Okay.
something.
And
What
don't
if we
use
wanted
this mesh.
Yeah.
Okay.
What if we wanted
Well,
to
yeah.
show like mock
Okay.
creation, like the
Okay.
shockwaves and
Just go
how
here,
those look in the inlet?
enter velocity, Mach number, is blank. Oh, sorry. I need to split the surface. Surface. I have a symmetry surface right now. Field, global, display.
Okay. I'm not sure how this looks.
I mean, we are still not done with the solution, right?
Mhm.
So once you're done, you'll get it. Something like this. You should get a shot this way.
So since the mesh is not created, then it's
no,
not
no,
gonna.
no. Since the solution, we are not still done with the solution. It's just like 5 iterations or something. You need to like give near about 1000 iterations.
Okay. How?
Okay, after this, just go right, JSON data. Oh, I've done that. So that's it. Then just go
Okay.
exit.
When you're talking about how many iterations you need to do, what is that?
That's the time, like the number of steps taken to convert your solution to get the values what you're calculating for.
Okay.
Just try doing it. You because we are using the options to like show it like pop up once convergence is done. It will show you like the solution is converged. Just give 1000 iterations. Once it is converged, it will stop.
Okay.
Okay.
Alright.
So it's just
Alright.
Shit. This did.
Alright. Well, I'll figure it out or try to.
okay. Yeah. Just let me know.